everyone, I'm going to go ahead and get started with today's video. Here's the notes for page 1 if you missed any of that information. And then I know on page 2 I had one class that we did not get to the greater example or the greater example. So I wanted to make sure that I went ahead and highlighted that that is here so you can fill that in on your notes. What I'm going to be focusing on as I work on these 3 examples for today is what I have highlighted here in red. Okay, I'm going to be looking at whether the absolute value is less than some number or if the absolute value is greater than some number. If it is less than some number, then we are going to be using our AND rule. If it is greater than some number, we are going to be using our OR rule. Okay, all right, so let's go and get started on the assignment. The 3 problems that I'm going to be working on tonight are number 3, 5, and 9. Number 10 and 11, do not scratch them off because we will be completing those in class. Okay? All right, let's go ahead and get started with these. Number 3 is an equation, not an inequality. However, we still are going to have case 1 and case 2 because it is an absolute value equation. So I am going to take what is inside the absolute value and I am going to set it equal to positive 16 and negative 16. All right, so I have 8 minus 3n is equal to negative 16. And sure, you could do the positive 16 first. Either way, they're going to both come out the same as we put them on the number line. Okay, and then 8 minus 3n equals positive 16. All right, I'm going to go ahead and solve for this. I have a positive 8 here, so to get rid of that, I subtract 8 from both sides of the equation. So then I have negative 3n is equal to negative 24. Divide both sides by negative 3. Now, since I'm dividing or multiplying by a negative number, if I was looking at inequalities, I would flip the inequality sign. But since it's equal, even if I flip that equal sign, it's not going to appear to be any different. Okay? Negative 24 divided by negative 3 gives me positive 8, and there is my first solution. For the second one, same thing. We are going to subtract 8 from both sides since it's a positive 8. Then I've got negative 3n is equal to positive 8. Okay. Now divide both sides by negative 3. And you are going to have a fraction. So if you want to turn this fraction into a decimal so that it'll be easier to graph on the number line, you're just going to do 8 divided by 3. And it is going to be negative 2.6 repeating. There's my second solution. So on a number line, negative 2.6 comes before 8, and they are both solutions. Okay? All right, let's go over to problem number 5. This one is going to be an inequality. Okay, I have that the absolute value is less than or equal to 3. Okay, so since it's less than or equal to, if I go back to our notes, less than or equal to means that it's going to be an AND statement. So this will be an AND. When I write this out, I'm still writing the 2 cases. First case, 2x plus 1 is less than or equal to positive 3. Second case, 2x plus 1. And now instead of being less than or equal to, I have to switch this one because I'm multiplying by negative 1 in order to make it a negative 3. Okay, whenever we have that negative, we have to flip it. All right, let's go ahead and solve this one. First thing I'm going to do, subtract 1 from each side. So I've got 2x is less than 2. Divide both sides by 2. And I have x is less than or equal to 1. There's my first solution. Next one, subtract 1 from both sides. I have 2x is less than or equal to negative 4. Divide both sides by 2. and I get x is less than or equal to -2. I didn't have to flip that inequality this second time because this was a +2. If it was a -2, I would have had to flip it. Now on the number line, I have -2 and +1. They are also equal to, so these are closed. And since it is an AND statement, my solution can be anywhere including -2 all the way including 1. So when I write this as interval notation, it can include -2, goes all the way to 1, and it includes 1. Okay? All right, one more to do here. Now we are going to go down to problem number 9. Absolute value inequality. This time here it is greater than, so it is an OR statement. The absolute's already isolated. So my two cases, first one, 4n plus 7. I'm going to go ahead and do the negative first on this one. So I'm going to flip the inequality and do -1. Then I have 4n plus 7 and is greater than 1. Okay? All right. So this one here, we're going to subtract 7 from both sides. So I will have 4n gives me -8. Divide both sides by 4, and I get n equals -2. On the next one, again, subtract 7 from both sides. So this time I get 4n is greater than, this one here is going to be -6. Divide both sides by 4, and we get n is greater than -3/2. Okay, or you can write it as negative is greater than -1.5. Okay, there's my two solutions. So when I graph them, I'm going to graph -2 first because that is smaller. Then -1.5. These are open circles. These are OR statements, so they point opposite directions. And when I am writing the interval notation, it goes from -infinity with the parenthesis because we'll never touch it, all the way to -2, which it does not include. We're going to jump over that gap, pick up again with -1.5, and go all the way to +infinity. None of them are included. Okay? All right, that is it for this video. I hope you all have a great night. Send me any messages if you have any questions.